Okay, hello, welcome to the first session of the Tech Talks this afternoon. Hope your lunch was great. I liked it a lot, so digest well and don't fall asleep. So, my name is Daniel Darmon. I work at Hybris in the Department of CEC, and today I'm going to talk to you about continuous integration that my team has put into place in mobile. I'm using automated mobile testing. Or else I like to call it developing mobile on steroids. So just the first start out, open question to you guys. Why do we test? Anybody have something that they feel brave in sharing? Any reason? Why is testing important? Make sure it works. Good. What was that? Good quality. That's good. I like that. Quality is important. Yes? Oh my god, bugs. Yeah, of course. Very important. So all these things are really important. You want to develop good quality software, get rid of the bugs before you get to the users, and this is what testing does. I mean, it's self-evident to anybody in the industry, but it bears repeating because it's integral to why we use continuous integration in the end. So another reason that wasn't mentioned, but was this morning in some of the talks, the workshops this morning, was that testing becomes living documentation for your software. When you develop software, you have a feature that you want to put into it. When you write a test, you're testing that, make sure that something appears, something is there, or something, you have an assertion. So you know that this test equals this feature, and it's as if you've written a documentation for the feature itself. So that's why tests evolve over time and then become living documentation. And the third reason is as a QA, it gives me a job. So that's also a really nice reason. So not only does little teams have to test, but big companies sometimes don't do such a great job of it. I'm sure we've all encountered major bugs, but none so maybe as massive as Apple encountered when they released their Maps application back in 2012. I'm sure this is infamous to a lot of you. It was quote-unquote life-threatening to people following directions in the Maps application in the Australian outback. So this is a result of not properly testing something with all relevant data that it could have consumed. And it had some interesting bridge structures in Niagara Falls. I don't know if that can actually work. So we want to establish that you have one chance to make a good first impression with whoever's going to be using your software. And once that's gone, it's gone. And I hope I'm making a good first impression on you, but unlike an application, you can't uninstall me. But an app, you can. You just say, this sucks, I got it off my phone, my tablet, whatever. So you have one chance to avoid crashing and burning, and that's it. So now that we know that testing is important, how do we specifically test mobile applications on our team? It's not rocket science, there's two major categories of testing, which is manual and automated tests. Manual, we're all familiar with. It's just using the device as if a user was using it. You're interacting with your hand, touchscreens. And this is UI level tests. And on the other hand, there's automated tests, which is more code level stuff. So unit tests, integration tests. And what's interesting for our team is that we also have sort of user level tests automated as well. And this is what I'm going to get into a little later. But these are two major categories. And they each have strengths and weaknesses. So for manual testing, what's really good about manual testing is that there's creativity involved. The manual tester is creative, they're human, they have their brain, they can say, I'm going to go outside of the confines of this test and do something else that's unexpected. Developers never thought of it before. So that's great. And it also is really good for manual testers to be in the place of the user. So if I see like a white button on a white background, I know that's a bad user experience, but an automated test might not catch something like that. The negative is that there's slow feedback. It takes longer than a machine, obviously. We're only human, and it's not scalable in the long term. So more tests, more tests, more tests. More testers doesn't equal the same velocity. So there's automated testing, pluses and minuses too. What's really good about automated testing is that you can have repeatable tests. The computer doesn't care if it does the same thing a million times, right? it does exactly what you tell it to do. So this is great, but a negative is that it does exactly what you tell it to do. Sometimes it's not what you want it to do, sometimes it's what you mean, and it's not always easy. So we found on our team is that a combination of those two things is what really allows us to have a good coverage of testing. So we have creativity and we have repeatability. We can make sure that everything was working in the past keeps working. So that's the preamble. And this segues into the major part of the talk is the CI system, which is the software that builds our software. And to open, there's a definition. The takeaway from this, you don't have to read it, I'm not going to read it, is that several times a day, code is committed to the repository, and then it's run against a series of tests or checks. And what really is nice about this is that you can detect problems as they arise. So every single incremental commit, you know that this went wrong because this commit went badly. And that's really valuable for pinpointing problems, right? And if everybody in this room knows CI, then it's probably nothing new. But as a starting point, CI is as follows. The developers commit code. You might notice them. Well, there's one over there, and there's one over there. These are on my team. They commit code, and it goes to the repository, and then it gets built, it gets tested, and then it gets results. So either you broke the build, you have reports, JUnit reports, and then it goes back to the developers who know whether or not they did well or not, right? If that commit has passed. For our team, we have taken the pipeline aspect and improved it towards more mobile-specific ways, and it looks something like this. So we have the jobs dispatch using commits. It's built and unit tested as usual. It's nothing groundbreaking. The distribution is something I'm going to be talking about a little bit more, but that's something mobile-specific where, well, I'll get to it anyways. We generate documentation from the code comments, and we have emulator tests which run in a virtual machine of an Android tablet or an iOS, device. So I'm going to be concentrating on these two are more mobile specific, and we'll talk about them more in depth in the next little bit. So Git is what we use for code versioning. It's an industry standard. I'm not going to get too much into it. The most important thing that you need to remember about, to know about this is that we have branches for our features. So when we want to develop a specific story, we have branch A with feature A, and we have branch B with feature B, etc. So that will be important later. So I'll just wanted to point that out. The unit tests and is what's next after we build the application. Unit tests are testing the smallest amounts of work that your code can do. So for instance, if you're making a calculator, you want to test the addition, 1 + 1 = 2, that's a good test. We have some simple commands that we use, and this is Gradle for Android, and we have a command line tool for iOS as well, just running our tests like that. And then the next step is one of the first really interesting part of our mobile pipeline is the distribution process. We use a third party called HockeyApp, and before I was talking about the Git branches having features. So branch A has feature A, and the way that we use this is that we compile an application with only that feature A, and then we have feature B app using branch B and feature C app using branch C, etc. And all these are uploaded parallel to each other inside of our HockeyApp account. And you can see that, well, maybe not so well, but the app names that end up in the repository are matched to the branches that we are working on. So if any given sprints, we have a branch named ABC, we'll have an app named ABC. And then the tester can download that specific branch and then see what's going on with that story, right? Or the product owner can see how things are going any point in time without bothering the developer. You can just go grab it and check it out himself. So that's really nice, and it works really well for us. So just go to the next part, is our process for document generation. Just use some very standard tools. There's AppleDoc for iOS and Gradle again for Android. This is like I mentioned, taking the code comments inside the code that the developer has written, and then generating nice, pretty HTML pages out of it. Pretty standard stuff. And this is the emulator test part, where I spend most of my personal time working on, so it's dear to my heart. It's using Cucumber, which if you participated in any one of those BDD talks this morning, that's the same thing once again. I'll be showing you a test in a second, but suffice it to say that we run it with the actual commands like so. It's a little bit more complex than that, but it's really simple to start it up once you have it set up correctly. And this is what an actual test looks like. It's written in Gherkin format, which is human readable text, and it's always in the format of when, and, then, given, and then you have your sentence. And what's really cool about these sentences is that they're like Lego blocks. You can shift them around, reorder your tests, make a new test out of existing steps. So once you build up your collection, you can create more and more tests. And this is a very simple one, and all it's doing is going to be checking the cart exists, and then it's swiping in and out. There's going to be a little demo of the application on the right there. But just to describe this a little bit further, we also have tags. You see at the top in blue, when we develop in our sprints, we have stories in Jira, and each Jira has a Jira number, so each story has a little number on the top. And every time we write a test to test for that feature being developed, we tag it with the same number. So at any point in time, we can look back in our test repository and see which test corresponds to which story in our history. So that's really nice, and sometimes it's really useful to see where things had gone wrong, etc. There's also anything you want to describe, you can describe it. So this is a cart test, so I put a cart tag. And what's nice is that you can run all tests relating to cart in your test set if you wanted to, just by specifying the tag. So you can have a filtering in place, just depending on what you want to do. So I'll just show you what it looks like when it's running. This is Android emulator. So like I mentioned, it's going to be opening the cart. It's going to log in. It's going to look at the cart, and then it's going to close the cart. It's very simple. And it looks like this. So logging in, and then it's going to, this is slightly sped up, even though it doesn't seem that way. It's going to swipe. That's the cart on the right, and it's going to swipe it back out, and the test is passed, because it doesn't see the cart anymore. So the new workflow that we have for mobile looks a little bit like this. So developers are going to be committing their code as usual, but now we have using Git, we have specific features per branch, and that goes again into the repository as before, no difference. We have our new pipeline, which has a nice distribution system and UI emulator tests at the end. And this goes to the developers as before. We have HTML document generation, and we have results, whether or not the build was green, red. We have lots of archives that are generated from the build, so we can have statistics over time over whatever we want. And what is nice is that the same pipeline can be used to work in every sprint and also be used for distribution or preparation for release, like handovers to SAP. We use the same pipeline, so it's no different from working than to releasing. It's very, I don't know, it flows well. So I'll just leave you with one final quote of CI. So CI doesn't get rid of bugs, but it does make them dramatically easier to find and remove. So thanks again. It was a little short. I didn't want to overwhelm everyone, and I know there's probably a lot more questions. My name is Daniel Darmon again. I work on Team Playmobil, and we're around the room here somewhere. And I wear a few hats at Hybris, and if you want to get into contact with me, I'm around for the rest of the afternoon. I have an email. Apparently you could also tag me on SAP Jam with @Daniel Darmon, or following the tag name Mobile CI. Any questions you have, go ahead, let me know. And since we are early, I guess we can answer some questions. Is that okay? Okay, that's it. Thank you. Sure. I started out with an open source project called Android x86 that they recompile the Android machine with for Intel, and you're able to run it on your machine a lot faster than what the stock used to be, a stock Android SDK. That has improved over time, so you could theoretically use what comes with the Android SDK. What I found to be the most useful and the fastest is right now is Genymotion. It's basically using that open source project Android x86, but it has a nice wrapper. They really smooth it out, because otherwise you would have to do a little bit of hacks for resolution to get to what you want. But with Genymotion you can do a lot of that. It has proxy support, which is nice for SAP. So we can actually access the internet with that. So that's what we're using for Android. And for iOS, we build the pipeline is all running on Mac Mini agents, and by necessity, because you can't run, you can't compile, you need Xcode, and Xcode runs in iOS, and the simulator is only available in iOS, in OS X. So both run on those things, and that's what we use. Genymotion, G-E-N-Y, motion. Yep.
So I saw you use the tool for the UI automated test.
Yep.
Have you ever used another one called Appium?
Appium? Yep. Yeah, I use it not to generate my tests, but I use it to query the elements on the page. So something I didn't talk about because I didn't think I had enough time was the way that we actually interact with the stuff on the page, right? Like you have an app, but how do you touch the button, login button? So we have element IDs in the application, in the code generated for the application when it's compiled, and Appium is able to detect when you click on an element, you have it surrounds the element, and you can pull out the ID that is necessary to interact with it. So that's what I use it for, but I know that you can script tests. This way, we have a lot more fine-grained controls, because all those sentences that you saw are implemented in the background with Ruby, and then you could really do exactly what you want, right? And you could reuse, which is nice, because as your test set grows, you need to reuse, otherwise it just becomes maintenance hell. So, yes, the answer is yes, I have heard and used it. Does anybody else have any questions? Okay. All right, thank you very much for coming. Enjoy the rest of the afternoon.